what they're able to do back in 2008 with a primate is have it learn through trial and error that by thinking it can move a robotic arm and feed itself. It didn't take too long for the neural interface issue to be resolved once people figured out you could implant electrodes on brain tissue and then take a biological signal and turn it into an electrical signal and amplify it. The monkey would begin to experiment and would think about where it wanted the arm to go. So it was learning, I have a new appendage. The same is true in people. As you can see, just 4 years later, we see it being done in humans.
45 minutes ago, I got to use a robotic arm for the first time, and I got to reach out and touch somebody for the first time in 7 years.
It also has some fun implications. If you see now, where do you imagine this going when you think of it as an offensive or defensive opportunity with respect to the intelligence community? The natural segue then would be, if I can send motor function from a brain to a mechanical arm, is it possible to send motor functions from one human to another human? So I call it the possession experiment. But essentially what's happening is when one person is playing the video game, they're not using their hands. They're simply looking at targets. What's going on in the other room is a transcranial magnetic stimulation device that creates a magnetic field that excites neurons. And it's the other man's hand that begins to move and hits the targets. So you've co-opted the portion of a body of another human, and then their hand can behave in the way that you want it to do. But the person on the receiving end described the sensation as rather odd. He said, I didn't know anything until I saw my hand beginning to move, and felt that it was something other. And its hand was moving. The hand could punch in a code. The hand could do a number of things. But the really fun part was that you're taking over somebody else's physical body with the mind of another human. And you have to begin to think either like doctors or like security and intelligence people, right? Can you actually send and receive sensory information, like the Matrix? I'll show you a little bit of this experiment. The short answer is yes. What we do know is that DARPA did get permission for 500 operations to do deep brain electrode implants. They haven't published anything yet, but my guess is what you're looking at is human-human thought transference, and certainly in the open science world, that was published last month. Actually, the brain-to-brain transfer of sensory information in 2 humans, and they achieved a success rate of being right 85% of the time. There's a biohacking community that is not part of the official science community that is busy trying to attach hardware to humans, and they do it in their basements. They study up on how to do the surgeries, how to connect devices, how to put motherboards in people. They're experimenting with CE6 and giving people with eye drops night vision. For several hours, a person receiving the night drops can see over 160 feet in the dark. So people are playing with chemicals to enhance the human capacity. They're also experimenting now with how do you add a device to the mammalian brain to give it an extra sensory ability. You may not want to detect infrared. You might want to have a room temperature detector of radiation, depending on what your job is in life. So when you think about it, the possibility now is there to develop different kinds of devices. They could be perhaps used either by intelligence people or by people in the military to have an extra ability to be able to see through walls, to see heartbeats. So this is where the race is right now, trying to merge quantum computing with what you'd call a wet hard drive with DNA. Merging DNA systems with quantum computing will be really quite an amazing and both lethal threat for that. It's a very active development in the field to figure out, can we erase memory? Can we modify memory? Can we change memory? The short answer is yes. Right? So the technical challenge right now is, how do we get a cell in there to do that in a human? I can assure you they're working on that in non-human primates right now. How many, what's the point specificity? Can we get it in there close enough to the hippocampus? Will those cells start reproducing in the next day, make enough of that stuff to wipe out a memory? Related to this, once you start thinking about memory, are chemicals that not only wipe out memory, but chemicals that enhance it. So if you want a better human camera, a better, an individual who can just go see and remember everything, that's the direction that the research in this lane is taking. In the last 5 years, what's been demonstrated is that you can train a fruit fly around an aversive experience, and you can transfer that memory to the brain of another fruit fly by manipulating the rods. And it gives it a memory for something that it's never had before, and then it reacts to the stimulus in the same way as the animal who did have the aversive learning. And so where are we with humans in creating false memories, giving them memories that they've never had? We've come a long way. She's done it with food. That was from her series with Alan Alda. She gave him a false memory that he'd been sick one time eating deviled eggs. And here they offer him one at the picnic on film, and you get the classic disgust wrinkle, and he said, no, I got sick one time eating them. It's not a true memory, it was planted. She's done it now with strawberries and ice cream, also done it with pickles, and has done it with alcohol. So think about it. If you change the past, you change human behavior. We are a case-based reasoning animal. When we think about what we're going to do, we think about the last time we did something, or what we heard about, or what we think it would have done. So to change human motivation, we don't have to persuade people. You can just change their memory. Think about the defensive and offensive capabilities of that.